Hi class, today we're dealing with section 2.2 and that deals with graphing and coordinates and finding intercepts and equations in two variables. So we're going to go ahead and get started. To find an x-intercept, you're going to plug in the value y equals 0. We're going to plug that in over here. We're going to get 0 is equal to x squared minus 9. As we learned last chapter, there's multiple ways of solving this. I'm going to use the square root method. And so square rooting both sides, I'm going to get plus or minus 3 is equal to x. So we actually have two x-intercepts. And that's okay, you can have multiple x-intercepts. To find our y-intercept, we're going to plug in x equals 0. So I'm going to get y is equal to 0 squared minus 9, which is just y is equal to negative 9. And so here we have two x-intercepts, one y-intercept. Alright, now it says find the intercepts and graph each equation by plotting points. So over here we want to graph this information. Those points are going to be 3, 0, negative 3, 0, and 0, negative 9. We could probably include a few more points, but we want to do that. And what we notice is that we only have a grid that doesn't have enough space for that. What I'm actually going to do is label this as 2, 4, 6, 8, and also here negative 2, negative 4, negative 6, negative 8, negative 10. And when I do that, that gives me the ability to fit all of this information on the graph. So you don't always have to count by ones. So here is 0, negative 9. Here is 3, 0. Here is negative 3, 0. And I know what shape it is. It's a parabola because it is an x squared. And so I'm just going to go ahead and connect the dots. And you're going to want to put arrows on each side of the line to show that it continues on towards infinity. And there we go. We graphed it using the intercepts. It says be sure and label the intercepts. This one is 3, 0. This one is negative 3, 0. This one is 0, negative 9. Continuing on to question number 2. We're going to do the exact same work. We're going to look for the x-intercepts by plugging in y is equal to 0. And I'm going to get 0 is equal to negative x squared plus 1. I'm going to go ahead and move the x squareds over to make it positive. And do the square root property, and I'm going to get x is plus or minus 1. And then to find the y-intercept, I'm going to plug in x equals 0. I'm going to get y is equal to 0 plus 1. In other words, y is 1. So those are the points 1, 0, negative 1, 0, and 0, 1. And I have enough space here to count regularly. So I'm going to go 1, 2, 3, 4. In fact, if you want to do it and skip every other line, you could. It's always up to you. But you always want your graph to fit in the window that's showing. So I'm going to graph this. I have 1, 0 as one of my points, negative 1, 0 as one of my points, and 0, 1 is one of my points. I do know that this is a parabola facing downwards. I'm going to plug in a couple more points just to make sure I hit them properly. Once again, you want your arrows to go off the screen, pointing that so you know that the parabola goes infinitely in these directions. And I almost forgot that it asked me to label the intercepts, so we're going to go ahead and put those labels on. 1, 0, 0, 1, and negative 1, 0. Sort of hard getting in there to label each one, but there we go. There's our labels. In your lecture notes, you have some definitions about symmetry, learning how to prove if a graph is symmetric with respect to the x-axis, the y-axis, or with respect to the origin. We're going to be going through some of those right now. We're not actually doing proofs, but I want you to be aware of the algebraic definition and that you need to use that at times when you want to show that something has a certain property. You don't want you to say, well, because it looks like it, but you want to be able to say, well, here's a point that I know. So for this one, it says find the intercepts. Let's go ahead and do that first. So the intercept here, it is 0, 1. And the intercept here is 0, -3. We have two x-intercepts, which would be 2, 0, and -2, 0. And we also have three x-intercepts here, 4, 0, the origin, and -4, 0. But the only y-intercept we have is the one at the origin. Alright, so we've done part A, find the intercepts. It says indicate whether the graph is symmetric with respect to the x-axis, the y-axis, the origin, or none of these. Now we can verify, we can visually see some things and we can verify it algebraically. So for this first one, in number 3, we see that there is no symmetry. But one way we can say that is for x-axis symmetry, we'd be looking for the point 0, -1. Because if there's xy on the graph, then we should be looking for x -y. Well, this point is not on the graph. I could pick another point like 1, 2 and say, if that is my point, I'm looking for -1, -2 to show y-axis symmetry. Well, that's also not on the graph. So it doesn't have x-axis symmetry or y-axis symmetry. Likewise, I should be looking for the point -1, -2 to look for symmetry about the origin. If you're wondering where I'm getting this information, it's because in the definition for symmetry, it says if xy exists on the graph, then you're looking for x -y, or -xy, or -x -y. So I'm looking for those points on the graph and I don't find it. Over here, we can sort of see the symmetry on the y-axis. If you imagine that the y-axis is a mirror, you can see the symmetry from left to right. But we can also see that for all the points that we had on the graph, if I'm looking for 2, 0 as my xy, then I also have -2, 0 on the graph. Now that's not a complete proof, but it is showing that at least algebraically the points that we know satisfy the quality. And we know it has y-axis symmetry. And then for the last one, it's hard to tell what's going on. You might feel like you have y-axis symmetry because we have the point 4, 0 and the point -4, 0. However, if you look at this point over here, it's mirrored over here where the x and the y are positive in quadrant 1, but the x and y are negative in quadrant 3. So this actually has symmetry about the origin. Alright. Like I said, these are not complete proofs in any way, but it's just using the definition above to help us see that something is true. Now looking at question number 4, it says draw a complete graph so that it has a type of symmetry indicated. It says it wants to find symmetry about the x-axis, meaning that for every point xy on the graph, there's also going to be x -y. And so if you look at that, 0, 2 is on the graph, we're looking for 0, -2. 5, 3 is on the graph, so I'm going to look for 5, -3. I'm going to go ahead and draw this in. And there we have x-axis symmetry. Now y-axis symmetry says if I have the point xy on the graph, then I'm looking for -xy. So I'm looking for the point opposite the 2, 2 would be negative 2, 2. And so I'm looking for that. Now I said that the previous questions in no way were we doing any type of proof. But for questions number 5 and 6, we're going to actually show something algebraically is true. And that way we can make sure that it's not just true for one number or for one point, but it's true for all points within the problem. So the test for x-axis symmetry says replace y with negative y and then simplify. So we're going to put x squared minus negative y minus 4 is equal to 0. That becomes x squared plus y minus 4 is equal to 0. And we're going to look at this and say, is this equivalent to our original equation? And it's not. It's the same everywhere except for right here. So it does not have that symmetry. No x-axis symmetry. Let's try it again for y-axis symmetry. And so the y-axis symmetry test says replace x by negative x. I'm going to put negative x. And when I simplify this, I get x squared minus y minus 4. Is this the same as what we started off with? Why, yes, it's the same. So we do have y-axis symmetry. Let's try symmetry about the origin. And when we do symmetry about the origin, we're replacing both the x and the y with negative x and negative y. So I'm going to put negative x minus negative y. I'm going to simplify. And that is not the same as the original. It's different right here. So I don't have symmetry about the origin. I'm going to have to say no, I don't have that. So for number 5, all we have is y-axis symmetry. We're also asked to find the intercepts for this equation. So we're going to find the x-intercepts and the y-intercepts. Recall that to find any x-intercepts, you want to plug in y equals 0. And so we're going to get x squared minus 0 minus 4. X squared minus 4 is 0. X squared is equal to 4. So don't forget that when you square root both sides, you have to put a plus and minus sign. You're going to get x is equal to plus or minus 2. We have two intercepts. That would be at 2, 0 and at negative 2, 0. Alright, let's look for any y-intercepts. And to do that, we're going to plug in the value x equals 0. And so we're going to get 0 squared minus y minus 4 is equal to 0. That just becomes minus y minus 4 is equal to 0. I get negative y is equal to positive 4, or y is equal to negative 4. So my y-intercept is 0, negative 4. Here is a graph on Desmos.com of the equation x squared minus y minus 4. As you can see, it has the intercepts at 2, 0, and at negative 2, 0, and at 0, negative 4. And you can also see that it, visually speaking, it looks like it has y-axis symmetry. Okay, we're going to do the same checks for number 6. We are going to check for x-axis symmetry, y-axis symmetry, and symmetry about the origin. We are going to check not just visually, but we're going to check algebraically. So we need to make sure that we plug it into the formulas using the test provided. To try to find x-axis symmetry, we are going to plug in negative y for every y that we see. And I get 4x squared plus y squared is equal to 4. That's exactly the same as the first original equation. For y-axis symmetry, we're going to plug in negative x everywhere we see an x. and that simplifies to 4x squared plus y squared is equal to 4. Once again, that's the exact same as the original. And for symmetry about the origin, we're going to plug in negative x and negative y everywhere we see it. It's important to use those parentheses to help us to apply the powers correctly. And this is going to be the same as the other one. And now let's test for intercepts. To find all my x-intercepts, I'm going to plug in y equals 0. And so I'm going to get 4x squared plus 0 is equal to 4. I'm going to get x squared is equal to 1. And I'm going to apply the square root property. And I'm going to put plus or minus on it. So I'm going to get x is equal to plus or minus 1. In other words, I get 1, 0 and negative 1, 0. To find all my y-intercepts, I'm going to plug in x equals 0. And so I'm going to get 4 times 0 squared plus y squared is equal to 4. Y squared is equal to 4. Once again, whenever you use a square root property, you have to put plus or minus. So I'm going to get y is equal to plus or minus 2. And so that gives me 0, 2, and 0, negative 2. Once again, I just go over to Desmos.com, type in the equation, and I just want to see the related graph. I want to point out that this graph does have the x-intercepts that we said, 1, 0, negative 1, 0, and the y-intercepts that we said, 0, 2, and 0, negative 2. You can see how it has symmetry about the origin, but also along both axes. And every time we have an equation that has x-axis and y-axis symmetry, both, it will have symmetry about the origin. Alright, checking for all the symmetries for question number 7, we're going to start off with doing the x-axis symmetry by plugging in negative y. And here, the right hand is exactly the same, but the left hand isn't. So this does not have x-axis symmetry. And then we're going to find y-axis symmetry by plugging in negative x. Make sure you put your negative x in parentheses, especially if there are powers or things that are being multiplied by it. And we're going to simplify that, and we get positive x to the 4th plus 1 and negative 2x to the 5th. And you can pull that negative out in front of the fraction. That's still not the same as original. So we're going to throw out the y-axis symmetry. And so to find symmetry about the origin, we are going to plug in both negative x and negative y. You get negative y is equal to x to the 4th plus 1 over negative 2x to the 5th. If I multiply both sides of this equation by negative 1, I will get that the negatives on both sides of the equation cancel out. And so it does have symmetry about the origin, whereas it didn't have any of the x-axis or y-axis symmetry. And it's possible to do that. It doesn't have to have both x-axis and y-axis symmetry to have symmetry about the origin. However, like the last question, if it does have both, then we do know it has symmetry about the origin. Alright, then we want to find the x-intercepts by plugging in y is equal to 0. And so you're going to get 0 is equal to x to the 4th plus 1 over 2x to the 5th. Looking just at the numerator, because that's what makes a fraction 0, you're going to get 0 is equal to x to the 4th plus 1. And so we get negative 1 is x to the 4th. And there is no real solution to this. You would have like the square root of I, which is not a real number. So we don't have any x-intercepts. And then we have all the y-intercepts. Let's plug in x equals 0. So I'm going to get y is equal to 0 to the 4th plus 1 over 2 times 0 to the 5th, which is going to be 1 over 0, which is undefined. So there is also no y-intercepts. Once again, we go to Desmos.com and we put the equation into the side, and we can see the graph. It has asymptotes, which we haven't really talked about in this class yet, but you can notice that the line looks like it's going to infinity in both directions, and it doesn't ever cross the x-axis and it doesn't ever cross the y-axis. You can see it does not have the symmetries, the x-axis symmetries, the y-axis symmetries, but it is symmetric about the origin. So if I looked at this point, it's and I look at its value over here, all the values are negative. Alright, now the equation 8 is talking about the graph of an equation, which they're not giving us the actual equation. They're just saying, hey, we know certain properties of it. So we know it's symmetric with respect to the y-axis, and we know that 6 is an x-intercept. So for that, let's just draw a quick sketch of a graph. We know that 6, 0 is an x-intercept. So since we have those two facts, we can come up with the other one, because symmetry with respect to the y-axis means that if you have xy on a graph, then you also have negative xy. So since we know 6, 0 is on the graph, therefore we also know negative 6, 0 is also on the graph. And it turns out that negative 6, 0 is also an x-intercept. So there's our other one.